board, share my screen, and I'll show you our notes. If at any point in time you guys have questions or comments, I may ask you some questions. Please unmute yourself and talk to me whenever you get a chance. So I am going to share my screen. And then this is what your notes should look like. Give me a yes that you're seeing them, if you don't mind, if somebody will unmute. Can you guys see them? Okay, so what happens is I won't see much of the chat, so you definitely need to unmute yourself to let me know. I saw the yes in the chat, so I'm good now. But anyway, just throwing that out there. Go ahead and unmute to answer questions. Don't throw them in the chat. So right now you're looking at our notes, and we're going to go ahead and get started. And the first thing that we're going to talk about is graphing these coordinates. And what we're going to do is we're actually going to go down through the linear column first, and then we'll move to quadratic, linear absolute value, exponential. If for some reason we run out of time, we can always back this up, so don't stress out about it. I am not going to do every single problem because we have a lot to get through, but I may do just a couple of them. So if you look at the very first one for linear, remember linear is y equals mx plus b. I'm going to put up here as well the plus b, and the reason I'm putting the plus b is to remind you that there is a y-intercept. So remember the m was your slope, and the b is your y-intercept, and that's something that you will need to know later on. So make sure you make a note of that. So on this one, we have the equation y equals 2/3 x. And I can put this plus 0 or not, but that plus 0 represents the y-intercept. So I'm going to go through this one, but I'm going to ask you questions on the next one. So be ready to answer questions. That plus 0, again, is the y-intercept. So this is where you start graphing. So I'm going to start at 0 and plot a point. And then if you guys look, this is your slope, or we called it rise over run. So we're going to rise 2 and run to the right 3. If it were negative, we'd go down and to the right. So everything is to the right, okay? So again, up and to the right because it's positive. Now, to get the rest of the graph, you're going to drop down and to the left, completely opposite. So down to left 3. And if you don't have these notes printed out, that's okay. I did add graph paper to your module, so you can check that out in a few minutes. You can download that, or you guys can just sketch this on your paper. It's not a big deal. These are your notes. You use them. Again, I would suggest that you print them out, especially for this first unit. After that, when we're just solving equations, you shouldn't really need them, okay? So again, plus 0, that's where you start. It doesn't have a y-intercept. It has a y-intercept at 0. And then 2/3 is your rise over run. If you look at the next one, I'm going to try to keep that one up there while we're looking at this one. We have negative 3x plus 0 because there's nothing there. Okay. So where does this one start? Somebody unmute yourself and talk to me. Where does this one start?
The origin.
0. Yeah, the origin at 0, 0. I didn't have my sound on, so that was a problem. I probably couldn't hear you guys. So this is our start. And we put our 0, 0. And then how do we make negative 3 a fraction so that we actually have a rise over run? Somebody pop in and tell me.
Put a 1 under it.
Absolutely. So put a 1 under it. And then this is our rise over run. But this time, because it's negative, we're actually going to go down and to the right. So everything is to the right. So the down is with this. Negative 3 is down. This is a positive, so it's to the right. Down 3, to the right 1. Repeat it to get it all the way across the graph. Up 3 and left 1, and we connect the dots. And again, I don't want to insult your intelligence. This is just review basically for Math 1 and Math 2. So I think that you know how to graph a linear equation. We're just going to go over it. All right. And then on this last one that we have for linears, we have 4x equals 3y. Somebody tell me what's wrong with this. Not really wrong, but what do we need to do?
Move it all to one side.
What do we need to move?
The 4x.
The 4x is already by itself, right? So what do we need? See how the other ones are in y equals? Everybody see that? What's wrong with this one?
Do you
It's
divide
moving
it by 3?
Yeah. We got to divide by 3. Move the 3. The way we move it is divide because we're multiplying y by 3. And then our new equation, and I like my y to go first. It doesn't matter. I'm not picky about that. Okay, so we have y equals 4/3 x. Now it looks like the other ones. Okay, y equals 4/3 x. So where do we start?
At the origin?
Yes. And then how do we move?
Up 4, right 3.
Perfect. And then we can't get any more on this graph. We can if we like pull it up and write it off the graph. You don't have to do that, but then we'll go ahead and go the other way. So down 4 and left 3, and then we connect the dots. You should always try to graph 3 points. So we always have a 3-point minimum. Okay. For linears, you can do 2, but for everything else, you really need to do a 3-point minimum. Okay. Is there any questions on linear before I move on? Okay. The way that you know it's linear is it has the single x. So you may want to write that somewhere because I'm going to ask you again on your quiz, you're going to have to define which one is linear, which one's quadratic, absolute value, whatever. So linear is a single x. And its form is y equals mx plus b. Okay, so we'll revisit that in just a minute. All right. So then we're going to go to quadratic. In our quadratic, our normal quadratic is y equals ax squared plus bx plus c. That's what you guys learned in Math 1 and Math 2. So when you look at this, it's not really in that form. But then we're going to work in vertex form. So I'm going to show you what that is, and it makes it easy. Okay, so eventually you're going to see this form all the time in this course. So this is called vertex form. You don't necessarily have to know that right now, but I'm writing it like that for you. So we're going to take that 2 and put it outside a parenthesis. That 2 tells us how fat or skinny our u is. Is it really wide and open, or is it really tall and skinny? And then we don't have anything with that x, but it's squared. And then we don't have that c term or that y-intercept. These two numbers tell you where you start. So you start at 0, 0. And we will learn other equations where you have to pull that start point out in a couple days. Maybe, I don't think it's tomorrow, but it could be tomorrow. But we're going to start it at 0, 0. All right, so then to find your other points, for now, you have to plug in. I'm going to show you on the calculator as well, but for the first couple, I'm going to show you how to plug in. So we have x and y. I'm going to make an xy chart. If we have 1, we're going to plug it into the equation that we were given. This y equals 2x squared. And then 1 squared is 1 times 2 is 2. That means your coordinate is 1, 2, and you can plot it. And again, this is the crappy way to do it. It's not a fun way to do it. It takes a while. It's okay. Can anybody tell me what's special about a quadratic? Do you know its shape?
It's curved.
Yeah, it's curved. It's a U shape. Or if it's a negative, like that 2 were negative, it'd be upside down. So it'd be an N shape. What's great about it is it's symmetrical, right? So once you find one point on the left, you can mirror it on the right. So where is the coordinate on the left? I found the one on the right. Where's the one on the left?
It's the same one with a negative x.
-1, 2.
-1, 2. And if you plug that in, you plug in -1. -1 squared is +1 times 2 is 2. But again, you can mirror it to the other side. You don't have to do the work to find it. What's our point minimum? How many do we have to have?
3.
That's it. We're good with this. You know it's supposed to be U-shaped, so we're going to make it U-shaped and move on. Okay. Any questions on that one? When you look at the next one, I'm going to rewrite it in vertex form for you. What's that negative going to do to it?
It's going to curve downwards.
Yeah, it's going to make it turn over. So again, things that you already know. So I just rewrote it in vertex form so we could pick out the vertex. Remember, the vertex comes from here. So where is our first point?
0, 0.
Perfect. And then to find our second point, like I said, I just plug it in and make the XY chart. I'm going to plug in 1, and that's always the one I pick because it's easiest to plug into. And I have -3 times 1 squared. 1 squared is 1 times -3 is -3. So that coordinate is 1, -3. Where would the third coordinate be?
-1, 3.
-1. What's the second coordinate?
-3.
-3. Perfect. -1, -3. And all we need is those 3 points and we're good to go. Any questions on that one? All right, check this last one out. I'm going to rewrite it. What do I put outside of parentheses?
The exponent.
Ooh, look at the way we wrote the one above it. So I have it at the top of the screen there. What goes outside of parentheses?
A 1.
Right. Why is it a 1?
There's just one x.
Mm-hmm. Because there's always an understood 1 in front of that variable. Now, do you have to have the 1 outside of parentheses? No, but I want you to see that it's a positive. So that means it's going to point up. Okay, so it's going to be that U shape. So what's your vertex?
The origin.
Origin, 0, 0. I'm going to plug in 1 to get a point. So 1 squared is 1. And my coordinate is 1, 1. What is my other coordinate going to be?
-1, 1.
And if you want to keep going, you can. I also want to show you, I'm going to grab a calculator. So you guys can put these in your calculator. That's a terrible glare. Let's see if there we go. So we have x squared. And if you put it in your calculator and you check your table, you can see all your points. So there's your -1, 1, your 0, 0, your 1, 1. And the reason I'm showing you on this one is because this one's really tiny. So I'm going to go to my calculator and get my other points. So -2, 4, and 2, 4. So 2, 4, and mirror it to -2, 4, which will help me graph it just a little bit better. Again, you don't have to, it's a 3-point minimum. I just like to have it a little bit nicer on there, okay? Any questions on this one? All right, so we're gonna go to linear absolute value, and I really don't ever call it linear absolute value, so you guys can mark that out. They just wanted you to equate it to linear because it's pretty much exactly the same. So absolute value equations are basically a combination of linear and quadratic. So when you look at this, you're gonna have the 2/3, but instead of the parentheses, we'll have the absolute values, and then plus 0 like the quadratic, but the 2/3 is like your linear slope, okay? So absolute value you probably haven't worked with a lot. You do the same thing with quadratic. Your vertex is 0, 0, so we're gonna mark that. And then this becomes your slope. So on the linear, our slope was rise 2, run 3. So that's what we're gonna do. And does anybody know what shape absolute value is? Anybody? Okay, so absolute value is V-shaped. So again, it's like quadratic. It'll mirror itself, but it's pointed at the end. It's a hard V shape, not a round U shape. So you mirror it the same way. So over 3 up 2, or up 2 over 3, however you want to say it. And then you connect it and it's super hard V shaped. So you don't have to do any of the plugging in or anything crazy. You literally do your origin, your slope, and then mirror it. So origin, slope, mirror, okay? So look at the next one. What do you think that negative does?
Flips it over.
Upside down.
Absolutely, absolutely. Flips it over, makes it upside down. So we're gonna rewrite it. And again, on your quiz and stuff like that, you don't have to rewrite it. That's just me showing you what's gonna happen next, okay? So you're gonna see it in this form next. Our origin comes from 0, 0. How do we make the slope a rise over run? Remember, we add that 1 underneath it. So we're gonna go down 3 and right 1, down 3 and right 1. How do I get the other side?
Down 3 and left 1.
Yeah. And again, you could even say you mirror it, okay? So they are symmetric. So we want to make sure that it is symmetric. And then we have one more of these, and it's absolute value of just X. What goes outside?
1.
Absolute value of X, plus 0, plus 0. Where is our first coordinate?
0, 0.
Perfect. And then how do we move?
Up 1, right 1.
Our slope is 1 over 1, so up 1 over 1. And then how do we get the other side? We just mirror it. And again, you don't have to do all these points. It's just so you guys can see what it's supposed to look like. Any questions on absolute value? All right, we're going to go to exponential. Exponential is kind of the same. This is the weird one. So if I rewrite it, we have 2, and then that X is plus 0, plus 0. The problem is 0, 0 is not going to be your first coordinate, okay? 0, 0 is not going to be your first coordinate. And I'm going to show you why. If we plug in that 0, 0, so I'm going to do it up here, 2 times 0 plus 0 plus 0. I know this is a lot of work, but it's not, I mean, it shows the point. So this actually gives you 2 to the 0 plus 0. What's anything to the 0 power? Do you guys remember?
0.
If you have a calculator, try it on your calculator. Check this out.
1.
Yes, so when we try it on our calculator, 2 to the 0, 45 to the 0, 821356, blah, blah, blah to the 0. Y'all see my point, right? Anything to the 0 power is 1. So what is your y-intercept if we have 1 plus 0? What's 1 plus
1.
1, yeah. So every exponential basically has a starting point of 1. The only thing that will change that is if we add or subtract right here. So if we added 1 on the end, our y-intercept would be 2. Okay, so you just gotta play with this a little bit, but we always want to start at 1 for this day. Okay, when we get a +2, +4, +5, whatever, we're adding that to 1. So we're actually going to start at 1, and then you're going to have to do this like the quadratic where you plug it in. So we plugged in 0, we got 1. If we plug in 1, we get 2. So our coordinate is we plugged in 1, we got 2. If we plug in 2, we get 4. So our coordinate is we plugged in 2, we got 4. And then we could do it again and again. Now, what's going to happen on this side, it's going to go up very quickly. So 2 to the 3rd is going to be 8, and that won't fit on this graph. 2 to the 4th is going to be 4, 4, 16, and then so on and so forth. So it gets really quick. Now, on the other side, if I plugged in 2 to the -1, and you guys can do that on your calculator, you're actually going to get 1/2. So your coordinate is I plugged in -1, and I got 0.5. So 1 and 0.5. What's going to happen on this side is it's going to get very, very small, but never touch 0. So what it has is a horizontal asymptote. So I'm going to grab a highlighter and show you that no matter what, it will never touch the origin. So we're going to go as close as we can. And for our purposes, I go as close as I can, and it looks like a straight line, but it's understood that it just doesn't touch, okay? So you're going to do the best that you can with that, but do not let it cross over. So what I'm looking for on this graph is your y-intercept, some points, and that it doesn't cross your horizontal asymptote. So when you do it on your quiz, if it goes past that green line or it goes past the origin, then I'm going to count it wrong, okay? So be careful about that. We're going to do one more of these, and then we're going to move on. So y equals 3 to the x. We're going to rewrite it. 3 to the x plus 0 plus 0. Now, where is my y-intercept?
One.
1. Always at 1 unless there's something added to the end. To get the other points, we're going to do 3 to the 1, which is 3. I plugged in 1, I got 3. And this is plugging it into this equation up here, 3 to the 1. 3 to the 2, I get 9. So I plugged in 2, and I got 9. That one will not fit. Okay, so there's your 1, 3. What's going to happen on the left side? Or what's not going to happen?
Don't touch the origin.
Correct. It will not touch this line at all. If I do 3 to the -1, I get 1/3. So my coordinate would be -1, 1/3, which is really hard to show. But again, like I said, I try to keep it as close to 0 as possible. Don't go over, and then finish it out. And again, if you guys want to see, I don't know if I can get it close enough for you to see. And then, see how it doesn't touch? So I made it a little bit closer for you and a little bit closer. Sorry, it's been blurry this whole time. I didn't really know how to, this is a new document cam, so I didn't know how to fix it. But I do now, so I apologize. So any questions on those? All right, so we're going to move on to the next ones. And we have special ones, and these won't take very long at all. Y equals 2. If you guys look, it's going to be a horizontal line. So if y equals 2, I'm going to find 2 on the y-axis, which is right here. And then it's going to be a horizontal line. If it's the other way, x equals, and I'll pull this up so we can see both of them at the same time. If it's x equals -3, I'm going to go to the x-axis and find -3. And all of these coordinates will have an x coordinate of -3. So like -3, 1, -3, -4. Any of those coordinates right there, again, will be on that line. All right, so last thing that we're going to do is domain and range. And this is where it gets a little tricky. So what I'm going to start with are the easy ones, and then we'll move to the harder ones, okay? If you don't understand these 4 down here will be the ones that you have questions on. These you should be okay. So we're going to start with domain. And domain is how far to the left and how far to the right does it go. So on this very first one, you guys see how we have arrows right here. That means it continues to go forever and ever and ever. So as it's going down, we're not talking about down right now, we're talking about left to right. It keeps opening up wider and wider and wider. How far does it go to the left and the right?
Infinity.
Yes, and the way we write that is a parenthesis because infinity is not really a number, okay? It's just a direction. So it goes to -infinity because we always want the littlest one first. And then it goes all the way to positive infinity. We're going to keep going with domain because I think it's important for you to understand domain before we jump to range. So let's keep going to the next one and do our domain. If you look, also has arrows to the left and to the right. So what is the domain for this one?
Also negative infinity. And positive infinity.
Also negative to positive infinity. Okay, check out this one. Also has arrows to the left and to the right. So what's our domain on this one?
The same.
Mm-hmm. And then what about a linear graph? What do you guys think? Linear graph. Arrows to the left, arrows to the right.
Infinity.
Infinity, negative infinity to positive infinity. So notice that all of these normal graphs, no crazy points, like these have some crazy points with the dots and with the open stuff. They're going to have different domains, but these, because they have arrows on the right and left, are always going to be negative to positive infinity. That will never change unless they start putting these little dots and stuff on there. So anything to the left and the right, left and the right, is going to be positive to negative, or sorry, negative infinity to positive infinity. But when we start seeing these open circles, things are going to change. Okay, so these are the easy ones. That will always be normal. Range, that's a terrible R, is how far it goes up and down. Okay, so we always want to start with down first because that's our littlest. How far down does this quadratic graph go?
Negative infinity.
Negative infinity, because it goes forever and ever because of those arrows. But then we're bound at the top. It has a maximum point. You guys learned about maximums. And that's our maximum right there. Where is it at? What number?
3.
3. Now, when we write this 3, we're going to put a bracket. We put a bracket because that number actually exists on the graph. Infinities are not numbers. They are directions. It just tells you that it goes forever. It's not a specific number. 3 is a specific number, and it is a solid point on the graph. So you use a bracket. Okay. Look at your next one. It's kind of the same. But this one has a minimum. That means it's bound on the lower end or the bottom. So what's the lowest that this graph goes?
-4.
Is it a whole point or an open point? So that means we use a bracket because -4 is actually on the graph. How high does this graph go?
Infinity.
Forever and ever. And we use parentheses for infinity. Make sure when you're doing your quiz, you watch those parentheses versus brackets, okay? All right, so this one's a little different because it has this asymptote, right? What's that mean? What's this little dotted line right here mean?
It's never going to
Negative
touch it.
aspect.
Right. No touch. Okay, so it will not touch that. So that means how low can this graph go? Be careful on this. Where is your asymptote at?
-5.
So if our asymptote is at -5, but it doesn't touch it, we don't include it. So we put that parenthesis. So that's the difference. So on this one, it did touch it. So the 4 was included and we used brackets. This one, it doesn't touch, so we use parentheses. Okay. How far up does it go?
Infinity.
Infinity forever. Any questions on that one? That's the weird one, and only because you have to use parentheses rather than brackets. All right, well, what about this one? How high and how low does it go?
-infinity and infinity.
Linears will always be like that if they're normal graphs. Okay, so all our domains are the same because they're normal graphs. All of our ranges are based on if they have low points or high points that bound them. Okay, using that knowledge, and we move to one like this. Okay, move to one like this. We're going to start with our range. I'm sorry, we're going to start with our domain and do left to right. So I'm going to use this highlighter and then I might pick up another one or a different color. So we don't have any arrows. We have stops on both the left and the right. And the thing is, when you start, again, start on the left or the littlest, what do you notice on the left? What's that?
Open.
Open hole. So we need to make sure that we open a bracket. I'm sorry, open a parenthesis. A bracket is closed. And where is that at on the x-axis?
-5.
Perfect. Now, what you're going to do, and I'm going to use this Post-it note to show you, is you're going to slide over and you're going to see that every time a Post-it note touches, it's a closed point. So that means it's good to go until we get here. When we get to an open point, we need to stop. That is a bound. That point does not really exist. So when you put it in your calculator, it would cause an error on this graph. So where is that coordinate at on the x-axis? What number?
2.
2. So since it's not included, we use parentheses. But we still have some graph left. So the way that we do that is we put a little U, and that's called a union. So our domain is going to be -5, 2, as well as whatever comes next. Wherever you stop, you pick back up. So we pick right back up at 2 right here. And then we keep going and you see all the solid points until you get to our stopping or our bound on this side. And what is that boundary at?
7.
Count it one more time.
6.
6. No worries. Sometimes it's really small. I get it. And is that open or closed? It is closed. So we bracket it. All right. And that's pretty much it. I'm going to go through the domain on the other one just to get you used to the left, right, and then we'll talk about range. So your domain on this one, what happens on this left side? What do you see?
Infinity.
Yes, an arrow means infinity, and since it's pointing to the left, it's negative infinity, so make sure you denote that. As I move over, I'm solid, 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 solid until I get to this hole. Where is this hole at?
-2.
-2. And since it's a hole, we use parentheses. We pick right back up at -2, and we go and go and go and go until we see this hole at, where's this hole?
5.
At 5. Do we open it or close it? Parenthesis or bracket?
Parentheses.
Open, so parenthesis, perfect. Any questions on your domain? All right, so now we're gonna go range. Range is how low, so I'm gonna do it in blue. How low to how high. Be careful because this is where the arrows may throw you off. So we'll start with this one that doesn't have any arrows. So let's look at our range. What is the lowest point that you have on the y-axis?
-1.
Is it open or closed?
Open.
So you use a parenthesis, -1. We keep going up and we stop because there's a hole that you guys see that there's a closed point. There's actually 2 closed points touching my Post-it note. That means it cancels out that hole. So don't stop if there are closed points touching it. You're just gonna keep going on until you get to your max point at what? What is your y coordinate?
6.
6. Open or closed?
Close.
Closed, so you use a bracket. So there is your range for that one. Okay. Check out your next one. You guys see this arrow right here? You have to be careful of that. So start with your lowest point on the range. What's your lowest point?
-5.
Open or closed?
Open.
The parenthesis, -5. As we go up, we see that there's a hole, but there's extra points there, so it closes it up, it cancels it out, it doesn't exist. And then we move up, and what do we see right there?
Negative infinity.
Not negative, but
Positive.
positive because we're going up. Up and down is what we're talking about. So it's actually positive infinity. So your range is going to be -5 excluded up to infinity because this point's up. All right, so 2 more and we'll quit. 2 more and we'll quit. So if we look at this one, we're going to start with our domain. Remember, domain is left to right. And again, remember I told you probably need highlighters. We're going to check this out. What happens on the left and on the right?
They're infinity.
Yeah, but we're going to say it goes to the left, negative infinity. But what happens as I go to the right? What do I see?
An open point.
Down.
Yeah, so where is that open point at? On the x-axis,
-2.
-2, and it's open. So I open the bracket, I open the parenthesis. I pick right back up at -2. And then I keep going and keep going and keep going. And what do I see on the right?
Infinity.
It goes all the way to infinity as it goes down, but we're not talking about down, we're talking about left and right. All right, so then we're going to talk about our range. Bottom to top right here. Be careful of this one, even though it has an arrow, it has an asymptote. That little dotted line tells you that it's bound right there, okay? If it didn't have that line, we would make sure that as we went up, it was all the way to infinity. So our range, what is our lowest point?
-5.
Okay, so it looks like that, but this one is tricky, and I didn't help with that. Can this arrow go below that point?
Yes.
Yes. So now, knowing that, you got to be careful because this graph is a little misleading. This is actually not our lower boundary. This is. Where is this arrow pointing? It's going to negative infinity. But as I come up, I do get to that open point. But does it not cover up right here? Does everybody see that? This one's the trickiest one on here of them all, okay? So because they shorted that arrow, you're not gonna think that it's actually there, but it is. And then this hole gets filled in because this point will touch it. So there's actually no open points at all until you get to this horizontal asymptote, which bounds it. It cannot go above it. So how high is that horizontal asymptote?
5.
And do I bracket or parenthesis?
Parenthesis.
Parenthesis, because it never touches that asymptote. Okay, so this is the hardest one. If you need more explanation, let me know and I will help you out. This one is cut and dry. There's no arrows or anything crazy like that. So we're gonna go left to right, last one. Left to right. Where do we start on the left?
-6.
Is everybody okay with that? Sorry, should be bracket because it's closed. As we go over, we see an open point at what?
-4.
-4. And since it's an open point, we use parentheses. We pick back up where we left off. And we keep going until we get to the end or another open point, which is right here at what?
7.
And since it's an open point, we use parentheses. Okay. For your range, we're going top to bottom or bottom to top. Here's our bottom point. There are no crazy arrows messing us up. So it is strictly bottom to top, nothing crazy. What is my lowest point?
-4.
And it's included because it's solid. As we go up, we see an open point right here, but we have a solid point touching as well. So we just ignore it and you keep going up until we get to this open point at what?
6.
And it's an open point, so we do parentheses. All right, so if you're good to go and you're good with the notes, you can move on. I know we have some more to do, but I will start them tomorrow because we won't have anything crazy. I don't think you have anything on your quiz that you need to do with actually making it. Your quiz goes through what we just learned. So you have to identify them. So I'm gonna go over that one more time. I told you linear was a single X. Sorry, quadratic always has X squared. Absolute value has absolute value bars. I know that sounds so trivial, but that's it, okay? Absolute value has absolute value bars. And exponential has some number raised to the X. So some number raised to the X. So something like 2 to the X, 3 to the X, anything that has X as the power. So your first 4 questions are going to be, look at the equation and tell me what it is. Is it linear? Is it quadratic? Absolute value. It's multiple choice. The next set are going to be how you tell from the graph. So remember, a linear is a line. Quadratic is U-shaped. Absolute value is V-shaped. An exponential, I call it a Nike check graph. So it just swoops up. So you'll have 4 graphs to choose which one it is. It's a very simple quiz, y'all. It's not going to take you very long. And then I think the last 4 questions, because I split it up, will be like these. Tell the domain and range. So question 8 might be the domain of this graph. And then question 9 would be the range of this graph. So I split it up into 2 separate questions so I could see if you're doing domain okay and if you're doing range okay. All right, so if you have any questions on that, let me know. And like I said, this stuff that we didn't get to today, we will get to tomorrow before we start. And then I will teach you the other stuff in no time. It's super easy. Does anybody have any questions before we walk away? All right, well, you guys go take your quiz. Like I said, it's not going to take very long at all. The last 4 questions will be the ones that take longer, last 4 or 6, because they're the ones that are domain and range, okay? Good luck. If you need any help, let me know, and I will get there for you.